Here that in this section we will talk about trigonometric substitution. So when you just see substitution, you just keep one thing in mind. You plan to use some simple form, or possibly after the substitution, you can just reduce the complex form into a simple one. Okay, so when we talk about substitution, you need to use some other variable to replace the original variable. Okay, so we in last semester we already know the normal substitution form, but this time we just try to use trigonometric function to replace some other variable. So there are three types. If you just encounter a squared minus s squared, or a squared plus a squared, s squared minus a squared, if you just have such a kind of form, you can just consider to use these three ones to replace the x. Why we do this? Because after we replace it, we can make the inside part to be converted into a perfect square. If we can have a perfect square, then we can just the square can be cancelled by the square root, so that it can make your integrand become simpler, so that you can just continue your integration. Okay, so and also please just to remember that after you just substitute by using the trigonometric functions, then you also need to keep one thing in mind, because as I always remind you, after you just conduct some substitution, you need, when you just calculate it to the end, you need to replace the original variable back. For example, you can see this integrand is blah 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 x. When you just integrate it respect to x, this variable, so supposedly the final result should be something blah 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 x instead of theta. So when you just replace it, you need to have its inverse function. Because only you can have its inverse function, you can just replace your theta back to x. So taking this as an example, that when you just assign s is equal to a tangent x, tangent theta, so you also bear this in mind that theta must be arctangent of x over a, and especially the theta should be constrained within negative half 1/2 pi to positive 1/2 pi. So if you forgot it, you can just come back to the chapter 7, that when we want to have an inverse function for the trigonometric function, we need to restrict its domain, right? So that's why I just try to emphasize here that you need to bear this in mind, that theta should be constrained within this domain, so that you can have the one-to-one property. Then you can have its inverse function. Then you can just you can just convert it back to the original blah 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 x. Okay, and by the way, if you want to get some other result about the triangle, you can just form the right triangle like this way, based on x is equal to a tangent theta. Okay, so next time we just stop here. Then you can see I just use this right triangle to have the final result. So you can notice that finally we still have the result about blah 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 x, right? From the very beginning, we just try to integrate something blah 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 for blah 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 x, right? But finally the result is still blah 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 x, and theta is just temporal variable. It's just help you to have the final result. Okay, this is just a simple review about how we just learned last week. So I believe you also noticed that after the class last week, some students just came here to ask me. So did you notice 4 plus x squared, square root of this one? We also need to think about when we just learned in section 7 of chapter 7. We can just we can just have the result related to hyperbolic function, right? So let me just show you. So in section 7, in chapter 7, we find this form, right? So we know the result should be arc hyperbolic sine of s over a plus c. Did you remember? At that time, I just asked you, we have several formulas based on the hyperbolic function, including the integration formula, right? This was done by section 7 in chapter 7. But right now, we can use trigonometric function to replace, right? We use trigonometric substitution. So in this section, we can let, because it has a squared plus s squared, so we can let s is equal to a tangent theta to substitute, right? Just like here, I told you that if you encounter a squared plus s squared, you can try to consider to use this trigonometric function to replace, right? So after some calculation, you can also get the result as ln, taking the absolute value of square root of a squared plus s squared plus x, then plus c. So because a squared plus s squared always larger than or equal to square root of s squared, so it's just taking the absolute value of x, right? So that we can make sure this term is always positive. So we can just simply remove the sign of absolute value. So the answer will be this way. So you can just notice that this one can be this one, right? Through this one. So different thinking can cause a different result, but actually they are all the same. Right? This is based on the hyperbolic function, so we can get a result. But this is based on trigonometric function trigonometric substitution, we can get this result. Okay, so that means I can just write down that, so we can conclude that this form, I can give you an example. It is equal to arc hyperbolic sine x plus c. This is based on chapter 7, section 7 of chapter 7. Then based on this section, we can also get the result should be this one. Right? So if you ask me, or if we just give you the same question, what the result you should present, the result you should present. So we will give you some hint that, for example, maybe we would just expect the result can be on the hyperbolic function, then you will come out this one. But if our hint just give you that try to use the trigonometric substitution, then your result should be this one. But anyway, these three things are the same. OK， 就是考试的时候我们会告诉你，请你是照这个双曲函数，还是用这个所谓的这个三角代换的方式去得到这个结果。那你到时候再以这题目的这个问法再决定要给这个答案或这个答案。但是无论如何，这三个实际上都是一样的啊。
最上面那个，
在上面。
最上面那个。
这个。对，是。sorry, I forgot. Okay. So let me just give you another example about this one. Okay. This question is just like if y is equal to 4 over s squared plus 4, please revolve y about x-axis to get its volume from s is equal to 2 to s equal to 2, is equal to 0 to x equal to 2. Okay, so actually these questions belongs to the scope in next semester, but also belongs to the scope in this semester. Let me just show you. So did you remember when we are just in chapter 5 or 6? We learn several methods to get the revolving volume. Did you remember? I give you a curve, then ask you to revolve this curve to get the solid volume. Did you remember? So at that time we just learned 3 ways. The first one is disk method, right? The second one is washer method, and the third one is shear method. You still need to bear these formulas in your mind. Okay, so this one is just talking about it. Okay, if this is y is equal to 4 over x squared plus 4, then this is the function, right? This is a curve. Then revolving y about x-axis. Okay, the statement just show that the revolving axis is x-axis, right? Then after just revolve it about the x-axis, then the start point is from s is 0 to s is 2. So what's the volume? What's the volume? So you cannot just forget the formula you learned last semester. So based on this, what method we will use? What method we will use? Shear method? Washer method? Or just simply disk method? You can see for each part we can always have the disk, right? So obviously it can be done by disk method. It can be done by disk method. So it will be pi. When we at some certain point x, we just use its height as the radius and revolve it. We can get this disk. Then we just accumulate all this. And finally we can get the value. Do you remember? So it will be pi r. R should be this one square. Then dx. Starting from 0 to 2. Right? This is disk method. Of course, at that time I also told you that you can solve it by disk method. You also can try to use the share method to solve it, but this method seems simpler than the share method in this case. Okay, so based on this, then you can suddenly find actually here. Did you notice it is just with the form of s squared plus a squared, right? So not just when s squared plus a squared is under the square root, but in the normal integrand, if you just find s squared plus a squared form, you can try to use the trigonometric substitution to do it. 我要说是说，它不单单只是在 square root 里面，你要去把 s 平方加 a 平方去换成一个完全平方的方式。你看，即便这个不是，你也可以用这种方式来解。Okay, so let's just continue. So when we just encounter this one, in the beginning, I just review the content we learned. We can try to let x be a times tangent theta. Okay, so in this case, we just let s is equal to 2 tangent theta, because 4 here is 2 squared, right? So we just let x be 2 tangent theta. Then we just immediately calculate ds over d theta. That will be 2 secant square theta, so that dx is equal to 2 secant square theta d theta. So we can continue to convert it into, okay, you can see this is 4 squared, so we can just get 16 as its coefficient. So we can have 16. Then we also move pi out of the integration, right? Pi is also constant. We just move it out. Then we just continue to convert it. This theta here, dx here could be converted as 2 secant square theta d theta, right? Because we have this. Then we can also have 4 tangent theta square theta plus 4. Then square, right? Because we already moved 4 square pi out of the integration, then we just have s squared plus 4 left. But don't forget there is a square here, so we need to take 4 tangent square theta plus 4 square. Then the numerator should be 2 secant square theta d theta. And the most important thing is, after you just convert it into something with theta, right? So original, its range is from x is equal to 0 to 2. So after we have this setting, have this assignment, then we need to convert it back to uh, 0 to pi over 4. Because why we can get this one? Because when s is equal to 0, then we can get theta it should be 0. Because when s is equal to 2, then theta should be pi over 4. You can easily to get this one by this one. Because when s is 0, only theta is 0 can satisfy. Because did you remember we just retrieve the domain for the theta, right? And when s is equal to 2, so 2 is here, so that means tangent theta should be 1. Only pi over 4 can satisfy. So don't forget, when you just convert this form to this form, you also need to change this integration limit. 哦，不要忘了在这边换变数的同时，你也要把变数积分的范围也要换掉，对不对？哦，那同时呢，因为我们的西塔有被限缩在就是负2分之派到正2分之派之间，所以事实上只有这两个点可以满足这个要求。哦 ，OK， so let's just continue. So right now, here we can see the 4 can be just the 4 can be cancelled with this one, right? Then we just have tangent theta square, tangent square theta plus 1. Then this part can be set as secant square theta. So in total, this is square, then still another square. So in total we have 4, right? But for the numerator, we have 2. So 2, 4, so we just have 2 left. So that we just have 2 left. So it will become integral from 0 to pi over 4 to secant square theta d theta. We still have pi outside the integration. So finally, we can convert it as 2 pi. The integrand become cosine square theta d theta. So finally, you can just continue to use the techniques we just learned for the integration about trigonometric functions. You can just reduce it. Okay, and finally, the result will be pi times pi over 4 plus 1/2. Okay, so in this case, what I want to emphasize is when you just actually 3 things. The first one is when you just talking about how to calculate the value, don't forget the 3 methods. Okay? And these 3 methods, you need to make sure what is the curve, what is the revolving axis, what is the integration limits from one end to the other end. Okay? This is the first thing I want to remind you. The second thing is, even though we didn't encounter square root in this integrand, see, we still have x squared plus a squared form, so that you can consider to use the trigonometric substitution to do it. Then the third thing I want to remind you is, since it's a substitution, it's a definite integral. So the so-called definite integral is, I give you a very obvious integration limits from 0 to 2. So after you just change it, you just substitute, you just do some substitution based on this. You need to change the integration limit in the new form. Okay. So even though this problem is not so hard, but there are something important that I want to remind you. Okay. Okay, then I give you also another example that I give you ellipse. This is ellipse 椭圆. So the function is a squared over a squared plus y squared over b squared is 1. So we want to get its area. So what is the answer? I believe most of you may know that, right? What's the final answer? The area. The area. (面积是多少？椭圆面积有没有学过？长轴、短轴。So the area, the final answer should be pi AB. Right? So for the special case, as A is equal to B, it will become a circle. So it will be pi AA, so pi A squared. Okay? So the final answer I will give you, but right now I just want to show you how to prove it. How to prove it? The answer is pi AB. So based on this, we just slightly convert the function as where x is from 0 to a. So right now I just focus on here. So if I can calculate this part, then after I get the result for this part, I just simply times 4. Then we can get the whole area for the base, right? So right now we just focus on this one. And when we just focus on this one, did you remember when we just learned in chapter 5, we talked about the Riemann sum, right? And at that time, we know we can just, at each point, we just use this high as high, and this is a small width, then times together, and we just accumulate each area, then finally we can get the whole area. Okay, so based on this idea, the whole area will be 4 times integral from 0 to a. Then its function should be this one times small dx. Right? I get this one first, then times 4, and totally I can get the whole area. Okay, so based on this integral, you can see we just suddenly find it is a squared minus s squared, right? you can see here. So based on this, we just try to use trigonometric substitution. So what form we should use for the substitution? X is equal to a sine theta, tangent theta, or secant theta. Sine, because if sine, we can have 1 minus sine square theta, right? So we will choose a be a sine theta. So after we have this, we immediately calculate d theta, dx over d theta, so that we can have a cosine theta, so that we can have ds is equal to a cosine theta d theta. Then we can continue to derive it. Then we can have 4 times b over a, because there is a constant. We just move it out of the equation form. We just move out here. Then we just have integral. Then we can have, okay, we just convert this first. This will be cosine theta, because here we can have 1, we can convert it as a square times 1 sine square theta, right? Then it will be cosine theta. Then original, it should be taking the absolute value. However, later I will show you. Let me just put the form together, and then I will show you. And then we just replace dx as a cosine theta d theta, based on this one, right? So right now we change it all in theta instead of all in x, right? And then where is the integration limit? Because when s is equal to 0, the theta should be 0. And when s is equal to a, then the theta should be 1/2 pi. So the integration limit will change from 0 to a to 0 to 1/2 pi. So here should be 0, and here should be 1/2 pi. Then since cosine original, it should be that we should have the absolute value sign here. However, within this range is positive, so that means we can move the sign. Okay, so then we can have, here we have 2a, so we can just cancel it. Then we have 4ab. Then integrate from 0 to 1/2 pi. Then since here is cosine theta, here is also cosine theta. In total, we have 2, right? So that means cosine square theta. Then Okay. 4AB, 4AB. Then we can have 4AB. We can have 4AB integrate from 2 by using cosine 2 theta. Then finally we can have we can 2AB theta plus 2 sine 2 theta from 0 to 1/2 pi. Right? Okay, so the answer will 2AB times 2/2 pi plus sine pi over 2 minus all 0, 0 plus 0 over 2. So finally, this is also 0. So finally, the answer will pi AB. Right, so you also can see we also use some techniques. The first technique is because we encounter s squared minus s squared. So we try to use s is equal to a sine theta. So based on the form you encounter, a squared minus s squared, you will use a sine theta. If you encounter a squared plus s squared, you will use a tangent theta. If you encounter s squared minus a squared, you will use a secant theta. Okay? Then the second step, when you just replace all x by using theta, then do remember you need to change the limit by using this one. Then finally, you can use some techniques we just learned in section 3. We encounter some integration about trigonometric functions, then you can use it to have the final result. Okay, so this is about the section 4. This is section 4. Okay. So then we will move to section 5. 对不起，我除掉一下好了。Okay. So then we move to section 4. The section 4, we will talk about the integration of rational function by partial fractions. What is partial fractions? So partial fractions means, so that means if we encounter qx over p of x. This is a rational function, right? So this is a rational function. So we need to convert the rational function into a summation of several partial functions. Then later on, I will show you how to convert it into some partial functions. So I will show you a simple example in the beginning that, for example, if we encounter this one, right? This is a rational function, right? This is a rational function because denominator is polynomial, denominator is also polynomial, right? So if we encounter such kind of form, do remember to convert it into several partial fractions. So for example, in this case, we are trying to convert it into, for example, we can decompose it as s minus 2, 3 times s plus 1, right? So we will try to decompose it as a times s minus 3 plus b over x plus 1, right? So if we can get a and we can get the b, so that we can just integrate respectively, right? These two forms respectively. So the answer will be something like a times ln taking f the value of s minus 3 plus b times ln taking f the value s plus 1, then plus c through what? Through, because integral 1 over x dx is ln taking as the value of x plus c, right? So don't forget this one. Don't forget this one. Then we can have this one. So the main step in this section is how can we just convert this into the summation of several partial fractions. So this is how we call it partial fractions. Okay. So in this section, we will learn some techniques to get the partial fractions based on the original rational function. Okay, so let me show you that how can we calculate this one, the so-called rational function. How can we do that? So the first step, step 1, f of x over g of x should be converted as q of x plus r of x over g of x if the degree of g of x less than or equal to the degree of f of x. Because if the degree f of x is larger or equal to g of x, we can use the long division 长除法 to get its quotient and remainder, right? So that we can make sure r of s, the degree for r of s must less than the degree of g of x. So this is the first step. If we just find the degree of g of x is less than or equal to the degree of f of x. And step 2, we need to know the factor of G of S. Because the G of S, we may factorize it. We can decompose it into several factors, right? So we need to try to know the factors of G of S. Later I will show you. Then step 3. Method of partial fractions. So we just divide the step 3 into several possibilities. The first possibility is if your G of X is equal to X minus R to the power M, then blah blah blah. Then you can try to guess your R of X over G of X as A1 over S minus R plus A2 S minus R squared plus blah 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 tier A M over X minus R to the power M, where A1, A2, tier AN are constant. Okay, if your G of X is with this form, X minus R to the power N, so you need to try n terms, and each term, the first term is X minus, its denominator is X minus R. The second term with X minus R to the power square here to the power N. You need to try to get this, try to guess it is with this form. Then we need to try to get A1, A2, and AN. Then finally we just integrate them individually. Okay? So the second possibility is if your G of X is with S squared plus P X plus Q to the power M, blah blah blah. You can try your R of X over G of X could be similarly, it could be S squared plus PX plus Q, then S squared plus PS plus Q to the power of 2, blah 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 here, S squared plus PS plus Q to the power N, and its numerator will be B1x plus 1, A1, C1, sorry, B2x C2, Bnx plus Cn. So we also need to try to get B1 C1, B2 C2, Bn Cn. Then after we decompose it as this form, and then we just integrate each part individually. Okay, so that means for this one, it cannot be factorized. 这部分是没办法被因式分解的啊，我们只好这样做啊。Okay, and let me just explain the step first, and then after the break, we just go for some example. Then 3, f of s over g of s could be the sum of all partial fractions. So what is partial fractions? Partial fraction means each individual term will be the partial fractions. So we can just convert it from here to be the sum of the partial fractions. Then 4 equate the coefficient. Then we can get A1, A2, AM, or B1, C1, B2, C2, tier BN, CN. Okay, so let's just stop here and take break. And later on, I will show you some physical example. Let's just make some mistake. That here should be sign. Actually, I just made this mistake purposely. I just expect someone can come over to tell me that I just indeed made some mistake. OK， 我故意的，故意写错的，知道吗？没有啊，错了，是我自己弄错了。有时候我弄错，搞不好是真的是这样子啊。谁来跟我讲，我就会给他加分之类的。刚刚那是谁来跟我讲的？那个同学来跟我讲，我写错了。Okay, and by the way, maybe here I also maybe just explain this part too fast. I want to deliver it is 1 minus sine square theta to be cosine square theta. Then through this square root, we can come out cosine theta. Okay, thank you for your reminder. Okay. So right now I already show you how to convert the rational function into several partial fractions. Then let's just take a look at a practical example. For example, if I ask you to integral x squared plus 4x plus 1 over s minus 1, s plus 1, s plus 3. Okay, so let's just follow the steps and then step by step. The first one, we need to make sure if the degree for f of s, the numerator is larger than the degree for the denominator. So you can see here the numerator the degree is 2, right? How about the degree of denominator? How much? 3, right? So 2, 3. So that means we don't need to do anything for step 1, right? Then the second step is know the factors of g of x. G of x, so we are so lucky. They already give us the factors for the denominator. So we also don't need to do anything, right? So for the step 2. Then step 3 for the pairs of partial fractions. So if we encounter g of x is equal to x minus r to the power of m, then we can guess this one. So, okay, here we start to convert that since its factor is s minus 1 to the power of 1, right? S plus 1 to the power of 1, right? s plus 3 to the power of 1. So we will try to guess it should be with s minus 1, 1, then we have a, because we have this term, but its power is only 1. So we just need to guess its form should be a over s minus 1 to 1. Right? But for this one, x plus 1 is also, right? Because the maximum power is 1. So what we need to guess is here the max 1. So it should be also 1. So the second term we will try to guess is b over x plus 1 to the power 1. And the third one is c s plus 3 to the power 1. Right? Because its maxima is 1. So we just stop. Did you see our step here? If the maximum power is m, then we need to try, we just try tier m is enough. So since this is 1, so we just stop at 1. Okay? Then we just let this one, is equal to a over x minus 1, b over x plus 1, then c over x plus 3. So we can try to get s plus 4x squared, x squared plus 4x plus 1 should be a times x plus 1 times s plus 3, then b times s minus 1 s plus 3, then c s minus 1 s plus 1. It's easy, right? Then we can get a plus b plus c s squared plus 4a plus 2b x plus 3a minus 3b minus c. I believe you have the capability to check. Actually, let me do this one. It's easy for you because you can just expand it. Then you can see 1 will be equal to this one, a plus b plus c. 4 will be 4a plus 2b. Then 1 will be 3a minus 3b minus c. So you can just use these three equations, 3 variables, and we can have 3 independent equations. Then we can solve A, B, C. So I will skip the detail, but we can get A is equal to 3 over 4, B is equal to 1/2, C is equal to negative 1 over 4. I believe that is not the probability, but it really takes some time to study. Actually, it's also related to the linear algebra. 大二的时候学那个线性代数的时候，这个其实跟线性代数有一点点关系，很简单啊，这其实很简单的东西的哈，就是透过这3个等式去解出 A、B、C， 因为你有3个变数嘛。我从国小在国中啊，国中的不是学过2元一次方程式，2元嘛哈，6条线嘛，你有2个独立的方程式，是线性独立的话，你一定可以解出它们的交点，对不对？所以那时候不是讨论很多种情况，如果这2条线平行呢，就无解；如果这2条线呢，如果是互相线性独立的话呢，它就会有一个交点。如果这2条线刚好 exactly the same， 那你就无穷多组解，有没有？ 在国中的时候就学过2个元素的哦，那只不过这变3个元素，那到你学线性代数，那就是 n 个元素，就很大的矩阵，用矩阵用 matrix 来解哦，这个大2的时候的线性代数会讲哦。那 anyway， 你就是用暴力法都可以解出这3个变数的值哦。Okay. So after we get these 3 variables, then we can directly from here to here that it will become integral 3/4 over s minus 1 dx plus integral 1/2 over s plus 1 dx plus integral 1/4 over s plus 3 dx, so that we can just individually integrate them, then we can get this one at n taking f the value s minus 1 1/2 at n s taking s the value of s plus 1, then negative 1/4 at n s minus 3 taking x is s the value, then plus c, because it's still a it's not a definite integral, it's undefinite integral, so don't forget you need to add c here. Okay, let's just try others. Okay, this one, 2x cubed minus 4x squared minus x minus 3 over x squared minus 2x minus 3. Okay, we still need to step by step to check, right? Step 1, check the degree for the numerator. If the degree for the numerator is larger than the degree for the denominator. So you can see here the degree is 3. Here the degree is 2. So for step 1 we cannot skip it. So we just okay, maybe I just do it for you that it should be this one. So we can use this is to long division to get the result. So we can get it will be 2x. So we can have 2s squared plus 2 minus s, okay, 2x square 2x, okay, 2 plus 2x 2x 4x squared plus 6x, right? So we can have 5x minus 3, because its degree is larger than or equal to this one. So we need to try to have the form that become several terms. Then finally we can have 2x plus 5x minus 3 over s squared minus 2x minus 3, then dx, right? So for this integration is easy, right? However, we need to take care of this part. For this part, so this time is not so lucky as the previous one. Here we need to factorize. We need to factorize. Decompose it. So this term will be s minus 3 times s plus 1, right? So the maximum power here is 1, right? For s minus 3, the power should be 1. S plus 1 is also 1. So based on the previous, based on what we just learned in the previous one, we will guess it as a over s minus 3 plus b s plus 1, right? And I will not go to the details. You can just follow the way we just learned from the previous one. You can get A and B because this sum is much easier than the previous one because this sum we just have two variables. So through some calculation, you can get A should be 3 and B should be 2. So that means you can just your integration will become integrate 2x plus 3 over x minus 3 plus 2s plus 1. So finally, the answer will be s squared plus 3 times ln, taking as the value of x minus 3, plus 2 times ln, taking as the value of x plus 1. Then C. Right? You know what I mean? For this case, the degree for the numerator is larger than the denominator. So we need to have to use the long division to get to try to convert the form into this one. Then just use this one to guess. It should be with this one, and then you can get AB, and that follows the same way we just used in the previous case. Okay, this one is easy. And this one. Okay, this time is a little bit different. We still need to use step 1 to check. The degree here, the numerator is 1. How about the degree for the denominator? 4, right? Because this is 2, this is 2, totally 4. So this one, the degree for the numerator is less than the one for the denominator. So we don't need to do anything for step 1, right? For step 2, you can see here is s squared plus 1. It cannot be factorized, right? It cannot be factorized. S negative minus 1 to the power 2. So we need to try to guess. It may possibly, for this part, we need to guess it should be s squared plus 1, and its numerator should be ax plus b. Because don't forget, the maximum degree here is 2, so we need to guess the denominator here, its maximum degree is 2. So when we guess its numerator, it should be a times x plus b. So we have ax here. This is 2, and then the maximum should be 1. Otherwise, it should be divided by x squared plus 1, right? So it should be ax plus b. Then for this one, this is x minus 1 to the power 2. So we have two terms to guess. So the first one is s minus 1, then c plus s minus 1 to the power 2 to d. Right? Did you remember when we have x minus 1 to the power of s minus r to the power of n, we need to have n terms. So here is 2, so we need to try 2 terms. The first one is to the power 1, the second one is to the power of 2. The maximum is 2. Okay? So after that, again, we can just expand it. We can just expand it. And finally, we can get it will be integrate. For this part is that means we can get it will be 2x plus 1 s squared plus 1 dx plus I just skipped some calculation, but I believe you can do it by yourself. You can get A is 2, B is 1, then C is negative 2, D is positive 1. The method is still the same like this one. You can just expand it. You can just expand it and compare the coefficient. Then based on here, since we have 4 variables, so you can just image that because there are 4 variables. So you can image we will have 4 independent equations. Then finally you can get these 4 numbers. And the next step is the next step is we need to continue to integrate them. So please just see here. The first one is this one. So for this one, we can have ln taking absolute value of s squared plus 1. Why? Did you notice that if here is f of s, then here is denominator, right? Denominator is s squared plus 1. Its denominator is 2x. Exactly as the same as prime x. 我们注意到这个分母呢是 f of x 的话，分子刚好是什么 f prime x， 这刚好就是 ln 的。Okay, and how about this one? What is that? What is that? Arctangent. So the second part is arctangent x. Or we can also write as this one. Right? And the third one is negative ln taking as a real of x minus 1. And the third one is negative 1 s minus 1 to the power of negative 1 plus c. Why I just write it down as this one? Actually, the precise expression should be 1 over x minus 1. Why I wrote down as this one is because it's easier for you to image that, because this is x minus 1 to the power of negative 2. So after you just want to get this antiderivative, it should be like this one. Negative 1 times negative 1, then we can get positive 1. Then negative 1 minus 1, we can get negative 2. So that it will be just like this one. Okay, so finally, so in this case, don't forget this one, and don't forget this one is about arctangent. It's about arctangent. Okay, then I will show you a so-called Heaviside. Heaviside method. Heaviside method. The so-called cover-up for linear factor. The so-called linear factor is S power here should be 1. For this one, this is non-linear because this is S squared, more than 1 degree. So all its factors should be linear one. Then you can try to use the Heaviside. So that means the g of x for the denominator part should be s minus r1, s minus r2, blah blah blah, here s minus rn, and all of the degree here is 1. All of degree is 1, so that you can use the Heaviside, the so-called cover-up method. So that means, okay, I can show you that f of s over g of s. We can, if we have this one, if we can try to guess, it should be a1 over s minus r1, a2 over s minus r2, blah blah blah, here an over s minus rn. So based on this idea, we can get s minus r1, s minus r2, here s minus rn could be a1, s minus r2, blah blah blah, here s minus rn, right? For the second term, it will be a2, s minus r1, but skip r2, then s minus r3, blah blah blah, here s minus rn, blah blah, here an times s minus r1, s minus r2, here s minus rn minus 1, but skip s minus rn. It's easy for you. Actually, it's not that hard for you to image that, right? So then we just compare. We just compare the coefficient again. So we just focus on here. Maybe I use this one. We just focus on here, right? We just focus on the numerator and try to make the coefficient comparison. Try to compare its coefficient. So did you notice that if I use f, then use r1 as the input, then we can have a1 r1 minus r2, here r1 minus rn, right? And for the rest parts, because for the rest parts, they all have s minus r1. So when I use r1 as the input for f of x, then all the rest terms will vanish. will be 0 because each individual term have x minus r1。从第一项之后呢，后面的全部都消失变零，为什么？因为从第二项开始，每个人都有 x 减 r1 的因子，所以后面这些全部都不用算了，我们只要 care 其实这个。Okay, so for the rest one, all of them are 0, so that we can get A1 is f r1 over r1 minus r2, r1 over r3, here r1 minus rn. So we can have a hidden r1 minus r1, but just cover it, cover up. We just don't have this one. Cover it, but keep the rest one. Okay? So similarly, for A2, it will be f of R2, then R2 minus R1, R2 minus R2, R2 minus R3, here R2 minus Rn. However, R2 over R minus R2, we just cover it. Here, An, we will have f of Rn, then Rn minus R1, Rn minus R2, here Rn minus Rn minus 1, then Rn minus Rn. However, Rn minus Rn just cover it. Okay, so that we can get this one. So I can give you an example. For example, for this one, we try to decompose it. So we can get s plus 4. Then we need to decompose it, right? We need to decompose it. So we can have x. We can have x times s minus 2 times s plus 5. So we can try to guess it should be A1 over x plus A2 over x minus 2, then A3 over x plus 5. So in this case, if we want to apply the Haverside method to this problem, how should we do? What is R1? In this case, what is R1? What is R1? What's R1? 0. Please notice that you need to image that here should be s minus 0. So R1 should be 0. R2 is 2, right? What is R3? What is R3? R3 should be -5. Okay? So based on the Haverside, A1 should be F. What is F? F is here, right? This is F. F of R1, 0. Then R1 minus R1, R1 minus R2, R1 minus R3, but cover the first one because R1 minus R1 should be hidden. Then we can have F0, then we can 0 plus 4, then R1 minus R2, 0 minus 2, then 0 minus negative 5. Then finally, we can have negative 2 over 5. So similarly for A2, we should use f of R2. R2 should be 2, right? R2 should be 2. Then again, R2 minus R1, R2 minus R2, R2 minus R3. But cover up R2 minus R2. Then we can have 2 plus 4. Then 2 minus 0. Then 2 minus negative 5. Then finally, the answer will be 3 over 7. Okay, for the last one, I will skip and you can do it by yourself. So if you want to use Haverside cover-up method, you can make sure each turn should be linear, and its power should be 1. Then you can try to use the Haverside cover-up method. Okay, then for this part, we still have some idea. For example, using differentiation to find the A, B, and C in this case. So in this case, we can try to guess it should be. Since the power here is 3, right? So we need to try 1, 2, then 3, right? 1, 2, then 3. So we can continue to focus on S. A should be S plus 1 squared plus B times S plus 1, then C. So our purpose is to get the ABC, right? Our purpose is how to get ABC. So first one, we can let S is equal to negative 1. Why would I let S equal to negative 1? Because if S is equal to negative 1, this term will vanish. This term will vanish. Then we can get C. Right? So based on this, that S is equal to negative 1, then we can have negative 1 minus 1 is equal to C. So we can get C is equal to negative 2. Right? This is the first one. Then try to differentiate this one. We try to differentiate this one. So we can get, for the left hand side, we can have 1 is equal to 2a times s minus 1 plus b. Right? Because we just differentiate it, we can get this one. Then we just let s is equal to negative 1 again. we just let s equal to -1 again, so that we can get b is equal to 1. So if this one is star star, so let's just differentiating star star, then we can get, for the left hand side we can get 0, then the right hand side we can get 2a, so we can get a is 0. So then we can have a, b, and c, so that we can continue to integrate it, right? Okay, so in this section, all methods just focus how to get the coefficient a, b, c, or a1, a2, an, or c, b1, c1, b2, c2, and tier b and cn. And of course, if you can use differentiation, maybe you can also can consider the following one. For example, this is also in the example, we can try to assign some numerical value to the x, then we can try to find the ABC. For example, s squared plus 1 over s minus 1, s minus 2, s minus 3. So based on this form, you can see degree is 2, degree is 3. For step 1, we don't need to do anything. But then we can find here the degree is 1. Degree is 1, degree is 1. So what should we guess? The form we guess should be s minus 1. Since here is 1, so we also try to guess 1. Then we can set its coefficient is a. Then b, also for the second term, is s minus 2, 1, right? Then the third one is c over s minus 3, also 1. So again, let's just focus on here, right? No, actually it should be like, okay, it should be like, we can focus on s squared plus 1, then we can have a times lacking factors, b times lacking factors, c times lacking factors. So far, you still can use the first example I showed you to solve the problem. But the next step is, in the past, maybe we just explained it. And then we can get 3 independent equations, then we try to get ABC. But this time, I will not do this way. This time, let's just try, if we set s is equal to 1, what will happen? If we set s is equal to 1, we can get 1 squared plus 1 is equal to, if x is 1, this term, the second term and the third term will vanish, because they have s minus 1 factor, right? So we just have a times 1 minus 2, 1 minus 3, so that we can get a is 1. Then we also can set s is equal to 2, so that we can get 2 squared plus 1 is equal to, since we set x is equal to 2, for the first term vanish, third term vanish. 2. Oh, no, this should be 2, right? 1. Oh, this should be 2. So this term will be vanished. Sorry. This one should be 2. Huh? 1, 2. Okay. C is what? This should be 2. So this term will also vanish. So only the second one left. 2 minus 1, 2 minus 3. So we can get B is negative 5. Then we can set S is equal to 3. Then follow the same way, we can get 3 squared plus 1. Then for the right hand side, first term and second term will be vanished. Then C times 3 minus 1, 3 minus 2, so that we can get C is equal to 5. Okay, so in this section, the main purpose is try to find the A, B, C, this coefficient. So we almost reach the end of this section. So I also list the questions for your reference. Okay, so let's call it a day and see you on Thursday.